machines. One still shiny and new. The other is 2 centuries old and draws portraits. This one's earned its place in history. But this and all other robots are carving out their place today. Machines like this doll were very popular near the end of the 18th century, especially as amusements for the very rich. But their impact went far beyond their own age. For the knowledge of gears, springs, chains, and clockwork motors, which made such toys possible, was also the driving force behind the Industrial Revolution. The factories and foundries that sprang up during this period reduced the cost of goods, created wealth, and a good living for many people. But there was a darker side, too. The drastic shift in the economy plunged many people into poverty. Others labored day in, day out, under ghastly working conditions. It's important for us to remember this doll and its contribution to the Industrial Revolution. For today, we are experiencing improvements in technology and manufacturing techniques that may outstrip even the Industrial Revolution. We have many questions about this new technology, but the important questions for us don't concern whether we'll use it, for most surely we will. What we want to know is how it will affect our working lives and society. At the very least, it will be necessary for us to redefine our place in the culture as we confront machines they call intelligent. Artificial intelligence isn't at all like human intelligence. It's really the outcome of a special kind of computer program, like the one controlling this robot. By definition, a program designed with artificial intelligence makes decisions that would otherwise have to be made by human intelligence. It's true that many people try to make comparisons between artificial and human intelligence. Artificial intelligence has as much in common with its human counterpart as an artificial hand has to the real thing. The artificial hand is very important to someone who needs one, but it can only be a shadow of the bone and muscle limb it replaces. No artificial device has the qualities of movement, sensitivity, and versatility of a human hand. Something similar can be said about artificial intelligence. Intelligent computers can perform many useful tasks, but they do not have, nor will they ever have, anything comparable to human intelligence. Artificially intelligent machines are only acting intelligent, the way a performer acts out a role on stage.
Follow me carefully, it may prove a comfort. If we postulate, and we just have...
And like the performer, intelligent machines can take on a variety of roles, in each role acting a little differently, while meeting a different need. For example, the need to diagnose disease quickly and effectively has prompted many university medical centers to develop intelligent programs that simulate the work of doctors and laboratory technicians. It's common for a cancer patient, for example, to wait months or more for the results of laboratory tests to find out whether treatment has knocked out the disease. An intelligent program now nearing completion at the University of Chicago can make a diagnosis for certain kinds of cancer in a couple of hours. The program, called TICAS, uses a television camera to isolate cells suspected of being cancerous. It then compares these suspect cells with an encyclopedia of cancerous and normal cells stored in the computer's memory. Britanicus diagnosis results from a process that is a little like someone searching at an impossible speed through a bank of file folders, trying to match the suspect cell with every example in every file. The program looks for its match among such things as the cell's shape and the size and shape of its nucleus. If the program can't match the suspect cell with any cancerous examples from its Encyclopedia of cells, then the patient gets a clean report. Intelligent computer programs are very important in medicine and research, but the greatest need for these machines is in business and industry. This computer is used by an architectural firm to help in the design of buildings. The program accepts all the proposed specifications which make up the design for the building, including plumbing, heating, wiring, and so on. From these specifications, the program creates a simulation of the building, complete with all the necessary systems and subsystems. It can then look for conflicts, such as a water and electrical line both occupying the same space, and notify the operator. This kind of application, called computer-aided design, is making great contributions to many industries. But when most people think of intelligent machines, what they have in mind are industrial robots. There are many people who don't understand the differences between an industrial robot and a traditional automated production line, like this bottling plant. The plant can only fill, cap, label, and box bottles of soda pop. To do its job, it must perform hundreds of repetitive tasks. Robots, too, perform repetitive tasks, but robots differ because they can be changed, reprogrammed at any time to do a completely different task. Then reprogrammed again as often as necessary. The bottling plant, on the other hand, is forever limited to filling, capping, labeling, and boxing bottles of soda pop. Also, some robots have sensing abilities that can help if something goes wrong. The same can't be said of the automated line. When a robot is programmed, it means that a specific series of motions is stored in sequence in the computer's memory. This engineer is programming a robot to perform a complex series of movements involving 4 bricks and 3 eggs. Programming is usually very time-consuming and amounts to nothing more than marking points in space. Each point is assigned a number and is stored by the computer. The robot arm is then instructed to move from point to point. After all the points have been defined, it's then time to put them all together and see what happens. one mistake is always one too many. It's certainly no secret why robots have been so successful, so quickly adopted in industries here and abroad. Robots work 24 hours a day in the presence of poisonous chemicals, temperature extremes, and deafening noise. Robots aren't perfect, but they seldom get sick and never go on strike. There is no doubt that robots bring tremendous advantages to the workplace. But it is possible that during the decade ending in 1990, 3.5 million men and women may lose their jobs to robot workers, and millions more in the years beyond. Many people fear that these jobs will be lost forever and result in an economic disaster that would empty factories and warehouses all over the world, leaving millions not only without work, but also without hope. Of course, other people have different opinions about robots. Some believe that our lives will be improved and enriched with the adoption of intelligent machines. In fact, many feel that robots will create more jobs than they replace, and at the same time open up vast new markets for consumer products by reducing the cost and improving the quality of all manufactured goods. Some supporters even suggest that robots and other intelligent machines will take those jobs no human should have to do. They conclude that people will never again work under dangerous or tedious conditions. Those who disagree point out that any job is better than no job at all. We really don't know how many jobs will be affected by the introduction of robots. It's an issue so loaded with emotion that it's hard to trust anyone's statistics. We do know that the jobs most in danger of being eliminated involve well-defined repetitive tasks, especially factory work. But most people are surprised to discover the wide range of professional and semi-professional fields where intelligent machines will soon be taking over some responsibilities. One thing we know for sure: when machines take jobs that were once filled by hard-working men and women, these people feel unproductive, unimportant, and hurt. But there are ways to make these changes as easy on people as possible. For example, since the late 1960s, many newspaper publishers have had to install machines that operate more efficiently and with far fewer workers. At many newspapers, labor and management have gotten together to negotiate terms for the introduction of new technology. A typical outcome is for some workers, especially those with the most seniority, to enter retraining programs and take new jobs. Under such a negotiated settlement, people with the most to lose, especially mature workers, are protected. It is certainly true that fear of these machines runs very deep in our society. Robots have even been sabotaged by disgruntled employees. And there is a persistent myth that robots and other intelligent computers may one day take control of the planet. We know that comics and other books, plus television, science fiction, and horror movies have all contributed to this belief. But attitudes like these will soon pass away, replaced instead by newer ones. Because no matter what we choose to do for a living, nearly every one of us will eventually have to work with an intelligent machine. It is extremely important to learn what these machines are and what they can do. The first and most important lesson is that computers are tools. And tools have been important to human society for as long as there have been societies of humans. A glimpse at our past always reminds us that all tools, regardless of when they were made or what they were designed to do, have a lot in common. All tools work to shape and mold human culture. But on a day-to-day basis, tools are simply extensions of our natural abilities. For example, they give us a more delicate touch, more strength, more reach. These new tools, these intelligent machines, are no different in this regard, for they represent, once again, an extension of the human mind.